Hello boys and girls, welcome to Mrs. Bandu's Math Movies. We are beginning our Chapter 6, which is basically going to involve graphing mostly linear equations. Our objectives in this lesson are to find rates of change from tables and graphs and find slope. So this is lesson 6-1 again for algebra. You're probably going to want to have a straight edge, either a ruler or a protractor or something with a straight edge. We'll be drawing a lot of lines in this chapter, so you want to keep one of those handy so that you get good results from your pictures. Okay, first of all, let's start with our big definition for this section and really this chapter, slope. Slope is simply defined as the steepness of a line. Okay, but there's also several other ways to look at it as well. It's the vertical change over the horizontal change between two given points on a line. Rise over run. The difference in y values over the difference in x values, where x sub 2 minus x sub 1 is not equal to 0 because we cannot have 0 as a denominator. And basically, those are the main ways of looking at it. We'll also see a little bit lower here in our notes, and I'm going to skip down here, is also considered to be a rate of change, vertical change over horizontal change. So it's a change in the dependent variable over change in the independent variable. Okay, remember the dependent variable is the y variable. The independent variable is the x variable. So there's several different ways to look at slopes. All mean the same thing. Just depends how you want to talk about it or how it may apply to a particular situation. Okay. A line with a positive slope slants upward from left to right. So you might just take a straight edge, and this line would have a positive slope because as I look at it from left to right, it slants upward. A line with a negative slope slants downward from left to right. Okay, so in general, from left to right, if it's going downward, it's going to be negative. And I'm just drawing random lines here just to illustrate. Okay, a line with a slope of 0 is horizontal. Okay, so it could be right on one of these grid lines. It doesn't have to be, but it could be. Okay, horizontal. And horizontal lines and vertical lines have special situations. I remember horizontal as horizontal has O's in it, so it has a slope of 0, which looks like an O. A line with an undefined slope is vertical. Okay, we also often sometimes just say it has no slope. I'll accept undefined or no slope when you're asked these questions. To my knowledge, though, there aren't others, at least at this level, that would be acceptable answers. So we're going to stick with either undefined or no slope when we are describing the slope of a vertical line. And again, the rate of change, which again is slope or steepness, is the change in the dependent variable over the change in the independent variable. All right, let's move on. You might want to have a calculator. You probably don't really need one. The numbers in this section are really pretty easy, but I know some of you don't like to work in your head, so I'm thinking you can do without, but anyway. Okay. Finding rate of change using a table. For the data in the table, is the rate of change the same for each pair of consecutive mileage amounts? Find the rate of change for each pair of consecutive mileage amounts. The rate of change is the change in cost over the change in the number of miles. So the cost is going to depend upon the number of miles. So we see here, 42 to minus 30, and 150 minus 100. So that gives us 12 over 50, which simplifies to 6 over 25. Okay? Now I look for my next pair. So 54 minus 42 over 200 minus 150. So I get 12 over 50, simplifies to 6 over 25. And generally we do want to simplify to lowest terms. It keeps life a lot easier and smaller numbers to work with in the long run. Okay? And finally 66 minus 54 over 250 minus 200. So it gives me 12 over 50 again, which once again simplifies to 6 over 25. Okay, so the rate of change for each pair of consecutive mileage amounts is $6 per 25 miles. The rate of change is the same for all the data. If I were to graph this, then it would be a linear equation or a linear graph. Or I get a line, basically. Okay? So basically, I'm just taking, remember, the independent variable, the dependent variable, the change in cost over the change in the number of miles. Alrighty. Let's move on to the next one. Finding slope. Find the slope of each line. Now, I'm actually going to talk about doing this without having to do any math, and then show you how the math works as well. Okay, so what you can do is you can think of this as rise over run, and start at one point and go to another. So let's say I'm going to start at the leftmost point. To get to the other point, I would have to drop down 1, 2, 3. So my rise here would be -3 because I went down. And then from there, the run would be 2 to the right, so it's +2. So I would say that my slope is -3/2. Okay? Or I could have gone from this to this, a rise of 3, and then here I'm going left 2, so that's -2. Same slope. Doesn't matter where the negative sign is, because in the end they have the same value. Okay, so that's just by counting rise over run. Now let's do it mathematically. If you have a graph and can count the rise over run, that's perfectly acceptable. If not, though, here we want to go with this. So let's say our ordered pairs are 0, 4, and 2, 1. So we'll have the 0, 4 be the y2 value. So this is going to be 4 minus 1 is over 0 minus 2. So 4 minus 1 is 3. 0 minus 2 is -2. So that gives me -3/2. So the slope here is -3/2. When I simplify it, I almost always write that negative sign with the numerator so I don't lose it, so to speak. That's a matter of personal preference. Please be sure that you don't lose yours floating around somewhere. Okay, again, I'm going to do rise over run on here. So let's say I'm going to start with this one. The rise is 2. The run is 1, so the slope is 2. Or again here, I could do from here to this one, the rise is -2, down 2, and the run is left 1, which is -1, still simplifies to 2. Okay, so it doesn't really matter. We're going to start with this is the y2 value, so -1 minus 1 is equal to over -2 minus -1. Okay, so again, I do think sometimes it's helpful to write in, this would be x2, y2, x1, y1, and that's arbitrary. We will talk about that a little bit more in class, and have some already. Okay, so -1 minus 1 is -2, and then we have -2 minus -1, which becomes +1, which gives me -1. So this gives me 2. So the slope of this line is 2. which is what we found up here by counting as well. So either way. Okay, now in number 3, we do absolutely have to use this because there isn't any other way to do it. So remember, slope is going to be y2 minus y1 over x2 minus x1. Okay, so this is going to be x1, y1, x2, y2. Again, helpful to jot that down for yourself so that you don't mess up. Also, the x and y values come from the same ordered pair. Okay, so x and its partner y, x and its partner y. Just as a little check for yourself. So we're going to substitute in negative 2. Whoops, I'm sorry. Yeah, negative 2, negative 1 for x sub 2 and y sub 2, and 3, negative 2 for x sub 1, y sub 1. So when I substitute this in, x sub 2, I'm sorry, y sub 2 is negative 1 minus negative 2. And then I have x sub 2 minus x sub 1, which is 3. Okay. So negative 1 minus negative 2 is positive 1. Negative 2 minus 3 is negative 5. So this simplifies to negative 1/5. So the slope here is negative 1/5. Okay. You have some quick checks to do here. Please review this. I know it may seem a little overwhelming and difficult. Bring in any questions you have and I will happily go over them with you. It's not hard, but it's also very crucial that you understand what you're doing. Otherwise, you will be lost in the rest of this chapter. So